And now, let's talk about production possibility set. Because each company, they have a set that make it possible for them to combine input to produce something. So what is this production possibility set? The production possibility set we use for the capital Z. For the production plan, which is a part of production possibility set, because here the production possibility set shows all the sets of technologically feasible production plan. So it means the Z is a combination of different Z3, Z4, up to ZL. So if we have a set of all the technologically feasible production plan, then we have a production possibility set. So it means we can produce any of this plan, and we can take any of this plan, and we will choose the plan out of them that reach us to our goal, which is profit maximization. So later on, we will try to find out which production plan is optimal plan that maximize our profit. So here, all vector of input and output that are technologically feasible. Again, when we are writing Z as a Z1 up to Z2, before we talked earlier that this Z1, Z2, Z3, for example, up to ZH is net input, after that is net output. So it takes all the input and output that are technologically feasible for the company to use them. And this Z provide a complete description of technologically identified with the firm. So it means based on the technology that the company has, so they can choose any things from like this production plan to produce their output to the market. So here, if we have only one input as a X, for example, this X is your labor, and we have one output as a Y, just we have one output as a Y. So one output, and also we have only one input. If you are going to like visualize this one, here Z1, which is equal to X, it shows our input from all the sets of production plan, all the combination of production plan. This is input. And this Y, which is Z2, is output. Because in this case, we only have one input and one output, then our Z capital is equal to just Z1 and Z2. So it means that in our production possibility set, we only have two, which is Z1 and Z2. And Z1 is X and Z2 is Y. So it means we are using X to produce Y. If we visualize this one, so this is X, which is an input, and this is Y, which is output. So this side, this part, is our production possibility set. Why it comes to negative side? Because as already we talked that we use a minus sign for the input. So here, as you see for the output, again we have a positive side, but for the input we have negative. It means in the production process we are completely changing input to the output. So that's why we are using the sign of minus as an input that we are bringing to the company, and after the production process we don't have any of that input again. For example, when we bring, suppose this input is milk. When we bring this milk to the production process and we produce this cheese, they're completely different things. So it's completely milk transformed to cheese, some different product. So we don't have any more milk in our, like, as a factor anymore. It's completely changing. The The shape is changing, even the quality is changing. The element that we have within the cheese is completely different that we have in milk. So also we have short-term and also long-term production plan. So basically, let's just skip this, what we have here. When we are talking about short-term production plan, in the short term, some of the input can be fixed. For example, in the short run, our capital is fixed. Our capital is fixed, but our labor is changing. Our labor is changing, but our capital is fixed. Suppose this classroom. In this classroom, we are not changing every day these chairs, this monitor, and the computer.
Not often. Not often.
Yeah, not often. So this is the capital. So the capital is fixed, but the labor is changing. So different professors coming, teaching, and sometimes even it's just the door is closed, there is no one, but the capital is exist here. So the labor is changing for using this classroom, but the capital is fixed. This is called short-term production plan. In the short-term production plan, we can say at least one of the input is fixed. But in the long run, what will happen in the long run? In the long run, everything will be changed. The capital is changing, the labor is changing, because like some years later, we need to like substitute this capital that we have. Or even we are going to like increase the level of production, the scale of our production. So we need more capital and more labor. But the short run, we cannot do that one. So it's the concept of short run and long run production plan that we have. In the short run, again, I can say, in the short run, at least one of the input is fixed. But in the long run, everything is changing. So another thing that we have in our production theory as a basic element, as a basic like concept, is the input requirement set and Isoquant. What is the input requirement set? It's a special feature of a technology is the input requirement set that we can show by using this set, which is V as a notation for the input requirement. Vy, what does it mean? The input that we are using produce Y. It's equal to a set of X, which is our input here. Y here is your production, your quantity, your output. And we are producing this Y with the combination of X, which is your input, with this input in RH plus. Why here then we use the notation of plus for the input? Because here we only consider the input. We don't think the other side of the production, because the name is set, input requirement set. The input that required for us to produce this level of output. So this X is in RH plus. As we already talked, that when we have Z1 up to ZL, for example, the H number of them can be input. So in this case, we are using the sign of like positive here, which they are such that this again, this vector of our input and output, this should be in our production possibility set. Here we have negative sign because we are referring this vector to the production possibility set. In the production possibility set, because we have both input and output, so we use the sign of negative for the input and the sign of positive for the output. But this X itself is positive because we are thinking only about the input here. And also we have Isoquant. What is the Isoquant? Isoquant is a curve, is a level curve. What it shows that all the different combination of input that produces exactly the same amount of output. So it means if we combine labor with capital, if we combine labor with capital, and we have this isoquant curve, this isoquant shows all the different combination of labor and capital that exactly produce the same amount of output or quantity. Either you use this combination, for example, this point is A, which is equal to L1 and K1. Either you use the combination of L1 and K1, or you use the combination of B, which is the combination of L2 and K2. They produces exactly the same amount of output. How we can write down? We can write down Y as a function of some labor and capital. But it shows this equality sign. It shows that all the different combination of labor and capital that produces exactly the same amount of output, Y. Or also, we can use another notation as a Q, which is quantity of your output. So all the different combination of capital and labor that you use in production process, but with that condition, which they give you exactly the same amount of output, is called isoquant. And the concept of consumer theory, we had a similar concept. What was that? In production theory, in producer theory, we can say all the different combination of input that produces exactly the same amount of output is called isoquant. But in consumer theory, we have all the combination of goods and services that produces exactly the same amount of utility. What was that? Yeah. All the combination of goods and services that provide exactly the same amount of utility.
Difference.
Yeah, it's indifference curve. As you see, even the shape of this isoquant is similar to the shape or the design of indifference curve that we have. Because here, just the element is changing. There we say all the combination of goods and services that produces exactly the same amount of utility, but here we say all the combination of input that produces exactly the same amount of output. Here is output, but there is utility, but here is input, there was goods and services. It's also the only difference that we have. So here, it's a big shape of like the isoquant and also input requirement set. So when it comes to the isoquant, this quantity as a Q, RQ, RY, anything you can use, just only to show that it shows the quantity of your output. It can be some function of X1 and X2. What does it mean? It means all the combination of X1 and X2 that produces exactly the same amount of output or Y. But how we can show the input requirement set here? The input requirement set is here. Not below the isoquant, but above the isoquant. So how we can write down? We can write down the input requirement set, Vy, Vq, as less than and equal to, no, sorry. is greater than and equal to f of x1 and x2. F of x1 and x2 is this curve, which shows your like combination of input. But the input requirement said Vy, which is this side. So this Vy, any point in here, is greater than or equal to this one. Because the input requirement said it starts from this curve and above. So then the Vy can be it's equal to something y this then and equal to f of x1 and x2. So this is your y, and this is your input requirement set. All the x1 and x2 that you have here, which is greater than this y, this is your y. And also equal to. So it means it's starting from this line, which is input requirement or Isoquant, sorry, it's Isoquant, above all the elements that we have here, that they are input requirement set. It means by the combination of these factors, at least we can produce this output. At least we can produce this output. But when we use like this combination, so it means we are using inefficient way. Because we could use this combination to produce that output, but now we are using this combination to produce that output. But it's feasible. It means we can. So it depends on how much efficiently we work. But this part is not overall in your input requirement set. Because if you even try to use this combination of input, you're not getting this output. So the input that you require for producing this output either should be greater than or equal to that one, not less than. So it's the input requirement set and also the Isoquant.